Okay, sir.
Hmm. Huh.
Okay, should I go?
No, no, I will introduce, sir. Just 1 minute for
Okay.
introduction. Yeah. Uh,
Okay, you should.
okay, fine. So, all the participant, I welcome you all, and I welcome the expert, today's experts, Vishwajeet as well here. Uh, we are in the I think this is a fourth day of our FDP, sorry, fifth day of our FDP. And today's first session is on generative AI in NLP, transformers, and GPT models by Vishwajeet. Shortly, I introduce him. He is experienced tech analyst, architect, currently working with Quantiphi Analytics, with a demonstrated history of working in the field of AI and ML. Best AI ML based software development and mentoring new interns and ML engineers. He has spent more than decades in IT industry and skilled in machine learning, natural language processing, and generative AI LLMs. AWS ML specialty certified, and also have experience working with a company like Samsung R&D, British Telecom in past. So I welcome Vishwadit. So and I request Vishwadit sir to proceed further.
Yep. Thanks, Raman. Uh, Thank you all. First of all, thanks for giving me opportunity to provide this talk. And just want to understand the audience, like, uh, 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 everyone can raise a hand who's aware of Chat GPT and ever use Chat GPT in the daily work, or like making PPT or something like that. Have anyone utilized the LLM like ChatGPT or anything like OpenAI, like GPT 3.5 or something? Please raise the hand. Okay, I think one hand is raised. Okay, not an issue. So I will. Mostly, let me share my screen. I will first start with the brief introduction, like what is the generative AI and LLMs and all. What is the industry first, why it's required, and why it's important, basically. And then we will go through some use cases industry wise, and then we will go more deeper into the technicalities, like how the architecture and all. And in the last 10-20 minutes, I will show you some demo of first, like how on the notebook we can do this, like can communicate with the like any LLM. And then I will show you some agent, like Gemini Pro, like agent based LLM, a multimodal LLM provided by Google, how it's work and how advanced it is. Okay. Want to make this session very, it's like you can just any question you can ask in between, make it uh, like talkative, like try to interact as possible. Anywhere you have doubt, any concern, any doubt, any suggestion and something, you can just come up and call out those things. Okay. So let's start with the so this is the do not graph, and this is heavily utilized in the industry. Any company who's pitching for the generative AI, machine learning products and all should follow, generally follow this type of structure and all. So to give you the idea, like what is this is like, so green part, so you can think it is as a brain of company. Green part is your data, basically, which come as a base to develop the any AIML. So if you understand AIML is computation heavy and data heavy products, uh, that's why in the past, if you go 15-20 years back, this fields, it's not in the that much not known, or it's not the part of daily life of ours. Uh, and if you research, these technology are not very new. There are many algorithms like embedding and all is from the 1980s. But as we advance ourselves and computation become cheaper and computation easily available, and we have clouds and all, to build the product based on this algorithm has become very easy. And that's why now AI ML generative AI is like so much everywhere in the market, and everyone want to adapt to this technology. This is more like a paradigm change, like happened in the past, like information theory, clouds, and computers, like done in the past, like 50s, 60s, and all. So this is an in a like 100 years one technology which changed the everything, the way we are doing. So if you look into the green part, it's more on the like if any companies like want to go and build the generative AI and all, they first work on their data modernization, platform modernization, and then they come up to build the AI/ML product. So to understand any algorithm, we need to understand where it will suit, where it will go, and how it will be built. So if you are a company and you are in on-prem, like on-premises servers and all you can't build AIML products because it's required GPUs and all, and which is very tough to procure and it's very costly. So first we have to move your data and everything computation to the clouds. So first part generally come is like data modernization, and next, once your data is centralized, it's on the cloud, and on top of that you generally build this AI advanced, the blue part, like basically the AIML based solution. And in that we have different like LLM generative AI is the one solution. We have like customer support which based on this technology, like document AI, intelligent voice assistant, AI based imaging, recommender system, video analytics, and multiple things. And it's not just one industry it's impacting. It's nowadays every industry is moving towards the digitization, and because of that, every industry is adapting this technology, like it's healthcare, bankings, retail, and all those industries. They are heavily utilizing these technologies and all, and the modalities which generally part of these things, like we are building the generative AI models on images, sounds, language, and multiple things. Okay, so this is the overall portfolio where generative AI suits. So just want to give you the idea like why we are discussing about this, why we want to learn about generative AI, we want to understand about the generative AI and how it will save the futures and all. Okay. With this brief idea about the industry, let me proceed around the what is the large language models and where it is like. So, language models is there in the past also. Large language models we call, which is trained on heavy data, like lots of data, lots of parameters, billions, millions of parameters. That type of language model we call as a large language model. Language model is basically a type of model where model try to predict the next word in a sentence. We call that type of model as a language model. And when the model which trained on that type of structure on a huge data with the huge structure, we call the language model. And every language model support the multitask. If it support around 10 tasks, we call as a language model. And as the things evolve, number of parameters is high, and the task it supported become huge, like 2030. Now we start calling it as a large language model. So there, it's not like only one company or one industry is trying to build this type of models. It's like daily there are some releases happening, advancement happening on top of the models which is already present. GPT's 3.5 chat GPT, which we call Da Vinci and all, came into the 23, and now after that we have lots of model which came on top of it, like Vicuna, which is quite similar at the GPT-4 released by different company. Now Meta AI, like which we call Facebook previously, come up with lots of open source model called Llama, which is easily utilized by the industry and even the institutes like R&D research institutes like colleges and all, and students can utilize. There is a Falcon series of model. There is a Red Pajama model is there. There is a entropy based model which called Cloud A and all. So we are bombarded with the models, and that's so like how much improvement is happening and how fast it's happening. Like every company is adapting. They want to this win this market. They want to adapt to this technology. Okay, so that's these are not hype like many people say this is hype and all, but no, like we are moving to the change. They will change the industry, but not so this is a change just started. At the starting we will not see the huge impact. We are slowly adapting it, but going forward after 10 years that it will show the huge impact, like how the digitization saw us in the past, right? So it's not hype, it's a reality and everyone is adapting to it. Okay, so first of all, what is LLM? Okay, so these are the model which train on the massive data set to achieve the advanced language processing capabilities. It's based on the deep neural network. If I will say the language processing capabilities like summarization, sort of like there are different capabilities of any language model like content creation, summarization, question answering, machine translation, classification, name entity recognition sort of work, semantic understanding, uh, sentiment understanding, tone understanding, code generation, and all. So there a single model can do all these tasks. That's a we call the model LLM model, which trained on style of language model, but as it's trained on the huge data, it's adapt to these tasks without getting any training, prior training and all. With the zero shot learning, it can do these tasks for you. And there are multiple models. It's started with GPT-4 and Google Bart and all, and now we have there are different, very vast variety of models which is available in the market. Okay, and now this is the LLM, like large language model, and how we can use it. A very simplified form, this is a very basic form how generally LLM works. Like as a user, if I want to use LLM, you can get any pre-trained transformer model from the market which trained on huge variety of data, vast data, and billions of parameter it consume. If you say there are lots of models, you initialize with 7B. That means 7 billion parameter, 14B, 14 billion parameters, 70B, 70 billions parameters. And if you are recall CNN, RNN time, we have parameter in the key 1000, 2000, and slowly sequence model have higher set of parameter that scale up to 30K and all. But these are different. These are like a bigger model which have billions of parameter, and that's why it's required lots of computation. And these models are very costly to train and costly to use also. I will come into that point also, like why it's costly to use and all.
Vishwajit,
Okay.
one request. Can you make a full screen so that visibility will be more?
Okay, let me zoom a bit.
Yeah, yeah, yeah.
Uh,
Huh.
so just 1 minute.
Yeah, yeah,
Everyone can see this. It's like, is it okay?
yeah, yeah. Okay, okay.
Okay. So to simply use this model, so there are multiple way to use this model. As you 10 days back, Satya Nadella, like Microsoft CEO, have giving a interview like SaaS is going to die, like software as a service. Like previously, we generally try to build a software like on based on Java or based on as a package we build and deploy on somewhere, and we use that type of software. Now everything is changed to PaaS or IaaS, means platform as a service or infra as a service, because these models are heavy. We can't deploy or use this model as a local. We have to go and buy some platform like AWS, GCP, Azure, Oracle are also moving towards the clouds. So these are like, that's why he's calling as we are moving towards the agent based Gen AI and LLM. We can't just work on the SaaS. We have to move to the platform as a service and all. But this is a very basic setup, like how you generally use when you want to use the system. You first give your text input, like books, Wikipedia, anything like text from the books, text from the Wikipedia, from the research, scientific research. That text convert into the tokens, and that tokens convert into the embeddings, and then that embedding will be uh, convert into a sentence embedding, and it will pass through your pre-trained transformer LLM model like GPT and all, and uh, it will give you, just 1 minute, let me, it will give you output in a vector form, and then through some post processing you can convert these into uh, your what you want, like predicted word, or you want summary from the scientific research journal, you want some summary, it will give you the summary. And that way it's work, like it will predict one word at a time, but it will give you finally the summary of all your scientific research. So this is a very high level overview, like how in a novice way how the LLM generally work. Like we have to give the input in a text format, then the input will tokenize, it will convert into the token embedding, and then it will transfer will get called the pre-trained model, and that will predict the next word, and it will be a cycle of prediction it will do in auto-regressive way, like the way word it's predicted will go as an input to the next decoder with the our encoded sentence, and it will predict the next word, and it will complete the sentence and all. Okay, so this is the very basic setup, like how the LLMs work. I'm hoping like as with your prior training, you are aware of like embeddings, tokenizer, like what these terms are. Like if you have any challenge on this, please call me out. Like you guys are aware of the what is tokenizer, what is embedding, encoding and decoding, right? Or I should recall it, like should give some context. And like, are you guys aware of like what is embedding in NLP, what is tokenizer? Please call out, sir. Like, otherwise I have to go to chat and see. Okay, please explain. Great. Hmm. Okay. Basically, you at the core level, everything is a bit, right? And the models which we generally use, it's represented in a vector form in our core system, right? So any text or image as input, if you want to give, we have to convert it into the number, and that will and models is also trained on the train as a vectors. It's have the numbers in a parameter, also is weight numbers, and feature is also represented as a vector and all. So sentence as a raw can't be understand by the model which we have trained, because it's a linking of lots of vector in the vector space and multi-dimensional space and all. So tokenizer and all help us to convert these sentences into the vectors which model understands. So basically, in the very simplified way, you can understand, like if there is a sentence, Dolly is a language model that can help you generate text for a variety of tasks. First, you split these sentences in on word level or character level, and using some embedding model like pre-trained models which generally train on some vector space, you, and each words have some representation in the vector space. Vector space is a multi-dimensional space where you represent your words in a vector form. So Dolly have similarity with some dictionary word which is part of embedding. The similar representation it will take from the embedding model. Embedding model is a model which represent your word into the vector form in a simplified way you can understand. And as embedding model have multiple dimension, and each dimension represents some type of feature of word. So a feature, as an example, I can give you Dolly can be a uh, like a male or female, and Dolly can be a like state name, Dolly can be a country name, Dolly can be a bank name. So the dimension is like a feature, and it can be anything. It's generally machine uh, itself decide what is the features. It's not as simple like this is just the male female feature. It can be combination of multiple features as a single dimension. So embedding dimension is like a feature which define the words in a 300 space, and each dimension is a like feature to define the words. And these words converted into the vector, and it will pass to the model which understand the vector only, and it will generate the vector output. Then we convert those output in a text format, and then we utilize it. Okay, so this is the way normal NLP work. NLP for us, it's look very simple: text as input, text as output, but a model understand only the numbers. So we need to convert first the text into vector, and that vector will go to the model, and model will generate some vector that will be reconvert into the words, which and then that will be go as a output to us. Okay, I will come on this deep level of technicalities on my second half. Just want to give you a few flavor like how it utilizes. I will not make it very tech heavy. uh, okay, so now let's mostly look into the application where the chat this type of LLM model is generally utilizes. So we generally use this type of model into the like content creation. Lots of places like web or multiple sites and all generally have writers to write the content around the travel blogs or about the some technology and all. So LLM can easily do the creative writing because it's trained on the vast variety of data, and as it's have lots of computation power, it can beat human in generating any writing, any story, and dialogue generation. There is a caveat, it's hallucinate, but that's a different thing. We can control it with some guardrails, but it's on very good accuracy on in content generation and augmentation, even beating the human on multiple places if it's utilized very systematically and all. Second thing is like summarization. Like if you, as a like faculty or researcher, just think you have to read around 30 pages of journal before giving lecture or any session, and you have 1 hours. So it's tough for you to go and understand each, go through each sentence and all. But using some LLMs like which is easily available without any internals you have to know, you can just pass those 30 pages, it will summarize for you, and you can just go through the summary quickly, and you can choose uh, the things you want from that. So 30 page will be maybe convert into a single page or 2 3 page with the concise summaries and all, and you can quickly go through it. Even summarization is one thing, and you are not happy with summarization, you can ask question from those 30 pages like where is the architecture explanation, what is the LLM architecture, how it works. Maybe it's there in the 15th page of your journal, and you have to go through, scan through all the 15 pages to find out like, okay, this is the content which talking about the uh, architecture of the LLM and all. But using the LLMs, it will give you the right content, right answer. It may be modified the answer in a easily consumable form, like you can understand with that capability. So that's also a very high use case. And question answering is very much utilizes like we as a industry, in industry, if I will say, the highest level of projects which we are getting on generative AI is around the FAQ and question answering. So like few more examples I will give you. Just very means like a simple example. Like I am a agent who sell the insurance, okay, and I am sitting with you on call, and I am explaining you policies like LIC policy or some SDFC or Go Health policy, and suddenly you ask me some questions, and policy is generally of 30 to 40 pages, right? And you suddenly ask me question around what is the waiting period for the cancers in my policy or some particular disease, and may I not recall it. I have to go through all 40 pages to find where that particular answer. But as I'm sitting with my laptop, I have the software on platform which is developed by someone company like us. They can just type it and within a second they will get the answer and they can reply back to the customer. So this will improve the customer experience, and even this will help to win the customer. So customer conversion or lead conversion, it will help. So we are building lots of product like that, like where just I have given a 40 page example. There are multiple companies which have like a stack of document around like uh, 100 to 200 PDFs, which have each PDF have 40 to 50 pages, and their expert want to get some particular answer, or they want to question for particular answer. Even company with huge database, and they want to scan, they want some answer from their database, we can plug on LLM on top of that database, and we can even generate answer from those data using LLM in a few seconds. So that's a power LLM giving us, a generative AI models giving us. Another use case is machine translation. I think everyone is aware of multi-language translation. It can do very good use cases like I have used the Google Translator. Like I am in uh, some Kerala's and all, and I don't know the Malayalam, and I have to find some store specific to some store. I just use translator camera and I put on hoarding of the store, and it will few second it will convert it into the English which I can understand. I know like this is the store I am looking for. So those type of like just not simple translation, we can, on top of those simple things, we can build a very uh, effective and easy to use solution which help every human in daily to daily life, right? There is a classification. Many industries is full of the example like spam detection, sentiment analysis, and all. We have NER model to detect the entities of the PDFs and all. Tone understanding, like sentiment understanding and all. And you heard of like a lot of you have heard GitHub pilot and all, and multiple code generation tool. So nowadays this is the industry, inside the software industry. We have agile way to develop software. So we want something which can help us to faster the development process. The things which can be developed in 30 days using these LLM and automatically code generation tools, we can accelerate the way of development, and we can reach that development cycle in just 10 days. So I'm saying in the starting phase, LLM will not replace human, but it will be add on to human. It will accelerate the productivity of ours by helping us like something like code generation and all. Like we just type like I want to get the logic of this, and you will get that in the JavaScript or Python, and you can just cut paste that logic rather than writing by yourself. So that will help you to accelerate the process of development and achieve something in quick time turnaround, and that will help to get something built very faster and faster. So these are the tasks which LLM do on basic to basic thing. This is a language model LLM. They are multi-model LLM. Like you will just put the image and you ask multi question. It will answer you all questions, all the scenario in the image. It can answer it for you. So these are the tasks. Any question here to understand the market use case? Any question? The example which I am giving, you have, please feel free to ask. Yes and no, sir, will help me. And I'm going very fast, or like it's very it's like something, some feedback will be also helpful. Like it's, are you able to make sense out of examples which I am giving, or it's I have to go with very more basic examples? Like
No, sir, it's okay.
it's okay now. Yeah,
Yeah, it's okay,
thanks.
and speed is also okay, no issue.
Okay, good.
Anybody is having doubts on the applications that we just discussed?
And also I'm most welcome for the, like if you have you've gone through some application and you want to understand if generative UI can be used there, I am happy to answer like something you think like it's a used by a generative AI used behind that, like you want to discuss, that's also help. I can happy to answer and discuss. So one question I have, like many of you are buying product from Amazon and all right? And nowadays you have seen like in the review section, 1 years back, Amazon don't have summary of review. It's like each person's individual summary you have to go through. You have filter like newer, positive, negative. But nowadays, if you look into the Amazon app, after each product there is a summary, like and bullet point, like what is positive, what is negative, but like a summary of reviews. Who all have seen that, and uh, uh, like that type of change in Amazon app? Like anyone experienced that? Any one of you? Okay. So please go and check. I think in the app, if you will see a new above the all the reviews, there is summary of review, which is a case of summarization. Like it will summarize everything, positive, negative for you, even catch the sentiment and bullet out the something which is goes as a green and which is goes as a red for that product. So this is helping you rather than going through all the review to understand the product. You can easily understand like what is the good in the product, what is bad. So basically, just think you are going to buy the headphone, and you go through the summary like this headphone has good bass, but it's have voice clarity issues. Battery time is very low. So rather than going through all the review, it will give you a summary of reviews at a first, like just one summary you can go through, you can understand this is the product you want or not. So that's a way it's getting utilized on multiple places. Okay. Okay. So few examples like I'm giving. So this is the example which I give you. This is the uh, like personalized product content recommendation for customer. So if you are going through the some customer like product, and you are going through some complaint like around that product, you can easily get the summary of it. Like, see, this product customer review says shipping delays is 25%, product quality 25%, customer reported issue with the product, 18% customer felt that response time was low. So you can understand what is the severity of these feedbacks and all. So it can generate a summary for you within a second, like around all those things, rather than going through all manually and all those aspects. Another example is like content writing. Many places, even in I can say in our daily use case, I am heavily using my company, similar to ChatGPT. We have developed something. I am using that to content to create the PPTs and sometimes the uh, content for my presentation also. So this helped me a lot, because these models are like an agent who has vast knowledge. Like it's a feed of multiple research paper, multiple books, and within a second it can give me the right answer which I am looking for. So this is like the power which receiving. Like just think of like this is it as a your helper to you, guys like who's a PhD, who is aware of everything, sitting next to you. And when you are writing something, you are just asking what will be the this thing, what, and it will suddenly, it will within a second it's answering you. So it's a that's a agent power, like generative AI and LLMs giving us. Okay. This is one more example which I have given you. Like there are like a bulk of documentations available to you, like thousand of reviews, thousand of emails, and you want to understand the sentiment out of you. So going through those thousand images, thousand answers, thousand PDFs, and doing getting the answer out of it, it is time consuming if we are going manually and traditional machine learning we are using. But with the augmentation power which come up with the LLM, we can do in a seconds and all, and it can solve the problem in seconds. This is the example which I talk about the GitHub Copilot, where it will help you to complete the codes, help you to generate the codes, help in error detection, debugging. Even it will help you to find the best pattern to follow. It will generate the documentation for you, and we have used somewhere where it's write the test cases for us, like with the 80% accuracy, where we have to do little bit changes, and we are able to generate the test cases in a rather than in a 10 days within the with 2 3 testers. We are able to write the test cases in using one tester in 5 days, 3 days, with the help of it. So this is the way it's helping even in all places for the IT, solving for the healthcare, solving for the insurance sector, banking, even for the developer like us. Also, it's helping in the day-to-day life. Okay. So now I have talked a lot about the goods. Let's challenges also we have to understand. So first, these models benefits, like it's a very it solves vast variety of NLP tasks like sentiment analysis, chatbots, Q&A system, and all. Even working as an assistant to us, text summarization, language translation, personalization for us, but come up with lots of challenges. Like it's for generic, it's very good. If ChatGPT is trained on Wikipedia knowledge, books knowledge, but if I will ask something specific to my company, maybe it hallucinate. It will give me the wrong answer, right? It will make the answer in a way it will looks like it's a 100% correct, but may the numbers and all is totally wrong. So just an example, I am using the model which aware of all the policy of LIC, and I am building a product for the insurance provider in the US, which have different policies. And I ask, tell me about the healthcare policy in AFLAC, because this model is not aware of AFLAC as a company, which is an insurance provider in the US, but it will try to make an answer for you. It will give you the hallucinated answer by making the understanding of LIC. But as a policies differs, even a single digit differs for one country to other country, it's giving us the wrong answer, right? So that is the ambiguity. It's because it's trained on the vast variety of data, so it come up with the ambiguity also. So to control that, we have to do some sort of prompting, which I will explain next. To utilize this language model, there is a technique we call prompting, and reading means like to there is another sort of vertical to like which we call prompt engineering, which deal with the prompting technique and all, and it's getting lots of uh, what I can say, it's getting like even more popular than nowadays than the normal programming language. Like many where they are hiring for prompt engineers and all who can write prompt for them to use the LLM. Okay. So now there is a, different type of language issues also, diversity which we have to cover. Scaling these models is also very tough because these are heavy models, lots of billions of parameter. To deploying it and scaling it is very very cost consuming, right? It's required. I am giving you example to deploy a simple LLM model, 7 billion parameter model, cost me $1.5 per hour on AWS. So it's $60, approx 60, 30 to $45, uh, 60 to I can say $90 per day. I have to pay to get one language model working. Maybe I'm not using it all the time, but to keep it on, I have to spend $90. So it's until I can make a business out of it of $90, it's not make sense for me. So that's a scalability issue. It's a very cost because it's required lots of GPUs to run and all. So that's a challenge we have. And not every model we can directly use. We have to make it control its answers and all. We have to put guardrails. That is also something which we have to understand. And it's a vast variety of application it can be used. You can fine tune those models with little bit of changes on retailer, life science, financials, legal, and anywhere you can train these models. Okay. Any questions here on the challenges and all you have? You want to discuss anything which you can foresee, which I am not calling out? Please open to call it. Okay. If nothing, then I will go next. I will now come to the some demos, like how the LLMs like generally use in the clouds and all. Okay. So basically, this is the so as I told you, like LLMs are generally getting utilized in multiple way as a platform, as a service, where you will get a full place agent where you have not to care about how you will communicate. It will give you very simple UI where you can utilize the power of LLM. This is one example where I'm using Google Gemini Pro. It's a multi-modal LLM which can understand multiple modalities. If I will say modalities, that means it can understand voice, it can understand text, it can understand image. These are different way of communicating, which we call modalities. And the model which understand different type of modalities, we call multi-modals. So for this example, I will show you the power of LLM. This is a prompt place where you can give the prompt and it's connected to model. You can write the question, it will give you the answer. Okay. So this is from my previous talk. I went to SIT. So this is the image SIT on Wikipedia. I have pasted this image and my model not aware of anything around the institute and all. And I will ask, please tell me the institute name mentioned in the diagram and something uh, historical about the institute, right? So I put this question and this is a image, just a image I've provided, and I want from the LLM. Okay, so see, as it's picked, like this is an institute name permanently displayed in the Siddhganga Institute of Technology. It's established in 1963. It's in Tumkur. It's affiliated from the VTU, and it's a reputed college. And as you can see, without giving any information, just I pick the image. I want the historical information around it. I can just use it, just prompt it, and it will give me the answers out of it. So see the power, like a model which is trained for you, and you can use directly. It is just pasting an image, asking question. It's briefing you everything. So that's the power of LLM. Any question here? There? Like how it works, like how it detect the image, anything you want to ask, anything you want me to try here. So it's just not like historical information, even it can be used as a image. You want to catch anything, detect anything, how many vehicles in image. There are two vehicle, one is motorcycle, other is a bicycle. So I even you can see, I can from the human eyes I can see a bike easily, but there is a cycle behind there, right? So the LLM can easily go through this and can make out of sense out of it. It give me two vehicles, right? So it can be used to detect the object also, uh, and even to get the boundary where it's okay. How many vehicles in image and give me coordinates.
Sir, is it, sir? Can I have a question?
Please go ahead.
Yeah. Is it like just you just give any building and it gives the history of that building? Is it like that? Without the name,
Yes,
for
sir.
example, here in the building there is a name of the Siddhaganga Institute of Technology. Suppose I don't give
We
the
can
name, I
use it.
just give a
It
building. Buildings can be very similar. No, many places buildings can be very similar. The
no, no,
architecture can be very similar.
it's basically pick the information from here. So if you're giving without any name, it I'm showing like what all information available. It can pick it. It's not a. It's basically working in multiple modalities. Like I am giving images, asking in text. It can understand. It's understanding image for me, making answer for me. It's look very simple, but it's very complex thing which is not available before. Text to text we can do, but image asking something and converting into getting the answer in text is something advancement we have using this Xenia, and within a second you are getting the answers. But one thing you can, I am I am getting the institute name to this, but it history I am not providing in this building, right? The historical information it's getting by itself, like from its knowledge, what the knowledge it's gained from the knowledge.
No,
So just a
with
few
the,
things.
yeah, that's the
Hmm.
question, sir. Like, just giving the name like that, even the names also can be very similar. For example, Siddhaganga Institute of Technology, like that, there may be it is in Andhra Pradesh also, it may be somewhere else also. Same name may be there for two, three different institutes. Sri Krishna Institute of
Hmm.
Technology there in Bangalore also, it is there in Coimbatore also, it is there in some other place also. So just by
Hmm.
giving the name, is it really going to be accurate one?
No, no. So just think it as a human. So if you provide the confusing information, I will just provide like Krishna Institute. And where is it? Like it's in the not in the maybe it's in three places: Andhra, Bangalore, Mangalore. So it will try to make a generic answer. So if it's not confirm about the place, it will maybe the main branch. It will give you the answer. So it's need a few contexts to make a right answer. So that's why I told you like to use its power. We have to use the prompting. We have to give some sort of context also to get the. Otherwise, it will hallucinate also. Like if you will not provide the right answer, the right context, maybe it will. You are looking for Bangalore Institute answer. Maybe it will give you the Bangalore Institute answer, right? Because you not provided the all the content in the image and all. So it's not that advanced. Like it can detect what's in your mind, but it's need something like meaningful to 100% meaningful things which not confuse this model, then it make lots of things for you. Okay, making
Yeah, it's
sense.
a very good technique, sir. As you said, using the image captioning, getting the details of that monument or
Hmm.
any historical place or anything. But as you say, that is the contents given. Is it like it is limited to that content, or is it trained like that to give some 10 lines or 20 lines like that, or that is itself is the knowledge it is gained? What is that actually?
So it's have the knowledge. This is the context you are giving. You are asking the question with the context. Like I want to get the answer about the Siddhganga Institute. So there are two ways. Okay. So I will go to the last one. Uh, like so I have just so see. Uh, So see, there are two way to use like right. So what power I am showing you here, it's not like it's trained on multiple information. So for now, let's I will delete this media. Okay, uh, clear it and tell me about Sid, Ganga Institute. Right now, I am providing like what I need. Right, this is a single modalities. SIT and it's given a 70 Northwest Bangalore. It's try to predict like what we are looking for, right? But I'm not I'm not telling in the text. I want to give that context using a different media. I want to just give the image and ask that question. So it's a powerful enough to understand what institute I am referring in the image. From the image, it's detecting the institute and making answer for me. So that's a power like con image contextual understanding it's making. Okay, but yeah, it surely need uh, like what institute you are looking for and all those aspects. Okay, otherwise it will get confused or make a hallucination for you. So we have to carefully use it. It's a powerful, but it needs some context and all to make a right answer, basically. And this is not only the use I will try to tell you, like this can be utilized in a multiple way. As I told you, like I am able to detect the vehicles, persons as object detection model also I can use. So I'm saying like single model can do a multiple task. So one simple LLM multi-model you can deploy, you can do multiple tasks out of it. You can insert PDFs, ask for summary, you can send image, ask for the content mentioned in the image, you can put image, you can ask the boundary boxes around the persons, like what all objects are there in the image, and those object detection output you can further utilize for the further processing. Like that you can do it, but yeah, it's also have some limitation. Yeah.
There is
Hope
one
making
question in the
sense.
chat box. How
Mhm.
can we generate synthetic data using generative AI?
So synthetic data, if so, generative AI will not. It can give the synthetic data, but you have to use the prompting. So you just tell me what type of data you want to generate. Generate. Uh, um, I will say. Just give me. So there is a separate architecture, which is not. It's based on the generative architecture only. GAN, which is my next lecture. Yeah, generative adversarial network, mostly used for the generating a synthetic data. Like the advancement happened in that GAN architecture. Now we have the diffusion models, which is the base of deep fake and all you have heard of, like which can create a fake images and synthetic images for you. So those are based on the GAN, but similar architecture, like they are also using the generativeness of the models and all, but not this LLM. Do the it can generate some text for you, uh, but it's not fully used to utilize for the generative the synthetic data. You have to provide the careful prompt to generate something out of it. Okay. For GAN model, you can specific GAN model can create a whole set of like if you want to create a lots of a synthetic research paper and all. So there are models, GAN model, which can do for you. Hope I answer your question.
Yeah, he's saying, okay.
Okay, tomorrow session we will cover that synthetic data generation and all. If you, I will note it down and I will cover that how it's generally done.
Yes.
Okay, okay. So this is the one thing we can utilize, but the important thing is like, what is the important? This is the package from the Google. But using the raw LLM is not as simple it is. There are multiple set of parameter and all we have to set, and there's a different technique which called prompting. Here the prompts is very basic because it's all the complexity taken care by the Google APIs and all. But uh, basically when we are doing in the raw world, like we have to take care of multiple things. I will go through that also. But before that, I will tell you about there are some sort of parameter which have impact on your answer. One is the temperature. So when we keep it 0, so as these models are trained on the vast variety of data, maybe your single answer have multiple, a single question have multiple answer. Okay, so it's have the diversity. It's maybe you ask a one question multiple times, you will get the multiple answer. Matlab, means it will generate answer in a multiple way. Maybe contextually it's same, but it's create a different phrases and all for you. So to control that diversity, there is a factor called temperature. If we want to control, we want to make it every time we call the model, we want same answer. We have to keep the temperature 0, so it will not diversify the answer. Otherwise, if we will increase it, it will go more diversity. Every time it will give you new type of answer. So how it's helpful? You want unique answers when you are asking a single MCQ questions from the model, right? Who is the president of India? So you want single answer, Damodar Das Modi or something. You don't want lots of things like he's the before Gujarat chief minister, he's Modi and he did this type of work and all. So every time you want like the model will answer the same answer. So you have to keep it 0. Otherwise, you want like model give multiple variety of answer, you can give make it 2. So multiple places where you want to make an interactive chatbot where someone come to your website and looking for some interesting answer, some new jokes and all. You make this type of parameter high so that every time new jokes and all will be coming out of it. But if you want to use it for some industry application, you want to keep this temperature 0. You want to go with the unique answer so that you can control the randomness in your application. So that's a one parameter. Second parameter is token limit. It's a very important. So when I am giving typing the text, each word is a token, and there is a sub level of a sub word can divide into the sub word also, which we call token. And as for the token, there is a pricing also, and there is a limit. If my page is of 40, my PDF is of 40 pages, and it have a text of around 40,000 tokens, I can't give all at a time to this model. So that's a limitation of LLM. LLM can take any length of context, but it's restricted. Like it can go to, it depends on the model. Some models can take 20,000, some models can take 8,000. So whatever context you are providing, like questions you are providing and context from where you need answer, you have to make in this limitation. Otherwise, it will take only the 8,000 tokens and it will neglect other. After that, it will not consider the answer which you will get from only 8,000 of tokens. Even your PDF have more than that, it will not give you answer from that because it's not considering those tokens. So that's a limitation, and it's a big R&D. Before that, it's only ChatGPT came up with 1024. This Gemini scale it to 8129. There are other advanced model even in this one also. Like there is a 20. Let's see this. Some small model is only 2048. They are like Gemini Pro. If it have 8192. So depend on the different type of model, number of parameter and all. It can there is a one more which can take 2 million context window. Okay, so so there are different model. You have to pay as per the context length you want to. So context length is very important parameter. Like token limit is very important. It decide the number of words you can give in your questions. If your PDF have more than or your document have more than 8192 tokens, you have to go with the pricey LLM or bigger LLM and all to ask the question. Otherwise, it will neglect the information after that. So there are multiple way to handle that. So one is the token limit. So these are the parameter you have to take care when you are working with the LLM. So these are the important parameter. Okay. Any question here on parameters or anything other than the one which from the Raman? Any other questions? Anything on multimodalities or anything? Okay. Good. Now I will show you an example like how when we are going with the raw model, like how we can do it. Okay. So this is like one notebook. Okay, I will share the this link. This is a one where deep learning dot AI hosting a LLM for you. There is no need to go to any cloud or pay something. You can easily go through this website. This is a part of lecture. You can check how LLM is working. Okay, it will take some time to load, but this is free. You can use it directly if you want to work on some LLM things specific. So to configure any LLM, I have shown you the one which came as a package from the Google, where it handle all the complexity. It will not open to us, but if you want to do on notebook and all, you have to import the models provider APIs and all, like OpenAI is like from the Microsoft. I have to first generate the API key from my account, and I have to set up the I have to import it and set up the key. Then I have to set up the model which I want. Then there is a format in which you have to configure the response API. Like I have to configure the model, I have to configure the message which I want to send, and the parameter. Like as I told, there are different configuration parameters, so temperature and all. Even the token limit also I can put if we want to restrict it. Okay. So once we have set up this configuration, then we have to we can start using it. So how it work, like it will, so this is this is the example where you want the summary out of some phrases you have, like around the panda, and you want a summary from this phrase, right? So this is the text which is context for you, and you want summary for this text. So what you will do, you will write the prompt. A prompt have three part. First, you have to give the instruction to model. Your instruction, like you are saying, what is the role you have to play to model. Like your task is to generate a short summary of a product review from a e-commerce site. Summarize the review below, delimited by triple matrix in at most 30 words. So this is the instruction you want your model to follow. So prompt have three components. One is instruction, another is context, and last one is the questions. If you have question, if you not put the questions in the instruction, you can also separately you can give questions if you want. So I have given an instruction, and I have given a context I have added here. I have given up. And once I will run this, I will just let me set up this. So this prompt will hit my model, and it will generate a summary for me. Like soft, cute panda plus toy loved by doubter, but is smaller than expected for the price, arrived early, friendly face. So this is the review for which we want the summary. It given us the summary for this. So this is more than 300, 400 words, but in 30 words, it's give me the summary using the LLM. So this is I just want to show you as in the Google, these promptings like for the syntax and all, we no need to go through those complexity. But in the real world, when you're working on some application and you have to develop your own application, you have to configure the models, you have to configure the APIs and all, then you have to write the prompt, then only you will get the response. Okay. So this is the another way to call the LLM. So here I am using the OpenAI. Okay. Any questions here? It's making sense for you guys, or like like you want me to go more deeper, like what it's doing and all those things?
No, sir, go
Okay,
ahead, please.
okay, great. Okay, so that's on the application side, which I want to show you, like how generative AI. Now let me quickly go through the technicalities, like how these models come up, like how what is the architecture and all. Uh, it's have. Okay. So now I will go through the working principles and like how it's work and the architecture it's follow and all. These models come up. The first, how LLM is starting point is the 2017 paper. where transformer model is introduced, which we call attention all you need. It's a basically a encoder and decoder based model where there are some layers of encoder is there, and there is some architecture of decoder. So encoders have the inputs which go with the input embedding plus the positional encoding, like where in the sentence your words lie, means syntactical information of your word in the sentence plus the semantic information we give it through the embeddings and encodings, and then it goes by the encoder layer which encode your sentence, followed by the decoder layer which will decode the sentence which you encoded and send it to you. So I will not go in lots of deep of like each things what it's doing because it's very complex to understand. There is a paper I can share if you can read it through, but it's have the different sort of layer. These layers generally encode, like it will convert those text into vectors, and also it will make a relationship between two vectors, means two words, like it's related to how it's related to each other. Okay, how much attention we will give on each words. Okay, so those type of things handled by this transformer architecture very well, and it's a self attention. There is no specific model we have to apply. It self learn. Like if I am saying, my name is Vishwajeet, and I am the technical architect in Quantiphi. It will understand from the first sentence, Vishwajit is the I in the second sentence, which is my name is Vishwajit, and I am the technical architect. I and Vishwajit is same person. It can make because the attention mechanism work in between. So I and Vishwajit have very high attentions relationship. So through this type of attentions provided by the self attention layer through these models, okay, and which is very important to understand the right semantics of the words and all. So this transformer model is the paradigm change. Before that, they are we using the sequential model, sequence to sequence model. Like in the your prior lecture, maybe you will heard of RNN, LSTMs, bidirectional LSTM. These are like sequence model, like one word at a time. But and the problem with those models, it take 3 to 4 days to train because it's follow one word at a time. So transformer, the best power of transformer is like it can be parallelized. The training time is low. That's why we are able to build the huge models like ChatGPT and all, because we can parallelize. We can send out whole sentence at a time rather than sending one word at a time. And the challenge there, like sequential model, you are aware like sequence of word, how it is coming, like what is the word on number one, word on number two, because it's go sequentially. But transformer, we are sending whole sentence at a time. So to get that sequence understanding, that's why we use the positional encoding, which you see here. And positional encoding help us to understand where it will lie in the sentence, and it parallelize the things. So transformer is the parallelized architecture, so it's trained very fast, and that's why we are able to train it on a scale like multiple huge set of data and all. You know. So simple form, what is the language model? Language model is the model which trained on the to predict the next token in a given sequence. And through this we will understand the language, whole language and semantics around the language which we provided to model. One word, it will predict the another word, and it will check like the prediction is correct or not. If it's and then the loss function will propagate throughout, and it will adjust the weight until it will predict the right. So that way the language model generally train. Okay. There are lots of before GPTs and all. There are lots of models release that is called T5 text to. There are multiple T is there. Text to text transformer. 5 T is there. That's why it's called T5. These models are first multitask model. So it can do the translation for you. It can answer your question. It can summarize your text. So this is the starting place where Google introduced T5 model, which can do multitask. And this is the place the large language model building started. We want to build a language model through which we can get multiple NLP tasks solved. One model for multiple tasks, and that's why these models called large language model. So T5 the starting point, and it is this model is also follow encoder and decoder architecture. We input the sentence through the encoder architecture, encode it, and one by one tokens we will predict through the decoder architecture. Okay. Then the best known model bot, I think many of you are aware of, which is fully based on transformer introduce, and it's trained of heavy data, and the bots have these T5 models are bigger, and transformer, if you recall, it's have two layers. One is encoder layer, another is decoder layer. So these are the encoder layers, and these are the decoder layer. So, and these are big models. So there is advancement happen. uh, Google's releases just a encoder layer, which they call the bot, which encode your sentence. There is no decoder layer. So this is that's why it's called bidirectional encoder uh, transformer model. So bot is there. This is bot architecture, which based on the encoder layer, encode the sentence for you in the vector space. Uh, this is bidirectional encoder. Why bidirectional? It's also important. Unidirectional means it can only understand the context before the word. So if I am encoding you in a sentence, if it's unidirectional, it will understand how are the context before the word. But if it's bidirectional, that means it's understand all the context, like doing today plus how are. So it's have knowledge of all the context around the word. That's why it's called bidirectional, because it's based on the transformer model. There is a then GPT model introduced by the OpenAI, and this is totally different in architecture from the bot, because it's a decoder based model. It's not encoder, it's a decoder based model, where we are only using the decoder layer of the transformer architecture, and we are using the unsupervised pre-training for these models. So it's very why we call it as an unsupervised pre-training. So basically, if you for the machine learning, we understand supervised and unsupervised. There are two type of training model is there. Supervised, where like I have lots of cat images, and I want to train a model to classify image like it's a cat image or it's not a cat image. So I have to explicitly tag the each data, label the each data. But unsupervised training method is where we there's no label explicitly required by human based uh, taggers and all. Model itself find the label. So unsupervised, how GPT's model do, they they just like a robot must obey. This is the sentence. So what GPT's model do, it take a robot must as encoding, and it will try to predict the obey. So if it's not able to predict the obey, like it's predicted exterminate, it will compare it with the correct output and adjust its weight to get the right output. So it's not, these labels are not generated by human explicitly. Model itself know what is to what for what it's need to be trained. It's itself finding the goal to be trained, and that is the biggest finding in the architecture. It help us to scale by a lot, because before in the sequence models and all, RNN LST, I have to provide the labeling, but these unsupervised model give us the excess. There is no human intervention required. GPT model can train on itself. I have to just provide the vast set of data, Wikipedia data, book data, and web crawling data, and it itself unsupervised pre-trained without any human intervention. So that's a big change, and that's why these models, big companies bombarded with lots of data and give it on high computation and let it be trained. And once it's trained, it's found out to be like it's performing very well. It's beating all the state of art model before the GPTs and all. and they started with GPT architecture. They follow up with GPT-1, and GPT-1 is like what they did. They first do the unsupervised pre-training, means vast variety of Wikipedia book data by following the next token to predict. And then once they have the unsupervised train model ready, they fine tune it with very few samples for different tasks. Like first is classification, very few sample of classification. With the vast knowledge of Wikipedia, it can able to understand what the task we are doing, and it can adapt easily to that task. It can do the classification of you, similarity for you, multiple choice answer for you. So unsupervised pre-training plus small supervised fine-tuning. These models are scaling out for multiple tasks and very powerful. That's a GPT-1 with few, then with more training, then OpenAI find out like if we will put more data, more computation I will provide, I will get lots of, the model will do very well from the previous models and all. So they started giving more data, more computation and all, and let it be trained. But to make it task specific, some conditioning they have added into the GPT-2 architecture. They so if they give the passage and separation colon summary, then it's trained for the summarization task. Same passage it will give and give the colon summary, then it will do the summary for you. Same passage comma translate you will give, then it will go do the translation for you. So that's a task conditioning. That is the earlier stage of prompting, which came become very popular in the 2023 GPT-4 release and all. But it's all started in 2019-20, where they start task conditioning, adding, and that's the starting point. So using this task conditioning without use in the final, once you have the final model, without any sort of example and all, just with the word, and you want to translate into English, it will understand what task you are looking for. So model itself learn, and it's self-learning. Like if I will give any language at the end, that means I am asking for language translation. That's so the model adaptability power, and that's give the hint. If we go in this direction, we can build a very powerful something which don't require any the way we are doing the lots of training and all. It can adapt to anything, and that's the base for the GPT-3 model, where we again goes with the more size, more data, more compute. But now we have further advanced the architecture to provide the more specific context uh, with examples and all. So model not learning the things, not remembering it, model not remembering the things. It's trying to adapt as per the task and all. So that's something advancement happen in GPT-3. With a few examples, you can convert the model into what you want. So the best part, the chat GPT model I have shown you, like I in the instruction I have given, I want summary in 30 words. Just giving the instruction, model become the summarizer for me, who can do the summary in 30 words. So that same model, if I will say, write a paragraph or 3-4 page or article or 3-4 page based on the above context, or context which I provide. So model will change without using any sort of training and all. It's just adapting, just with the some reference and example I am showing. So there is a key terms came out in GPT-3. One is zero shot, which means there is no example required for the model to understand what we are looking for. Just asking giving the instruction, it can adapt what we are looking for. One shot is a places where I have to give few example. So I will show you what is the one shot means. Like for example, mm, yeah. Uh, so here, if you see like here in this example,
I have given, I really enjoyed the movie today. Sentiment is positive. Text, my food was not great. Sentiment is negative. Now, if I am asking model, I will bet the video game is a lot more fun than the film. Uh, Now, just with the few examples, model understand we are now looking for the sentiment of the text I am giving. It's itself understanding like task here is to do the sentiment finding. So it's giving answer as positive. So without doing any training, without giving any instruction, model with few example, it's adapting to the task which we are looking for. So that's a change happen in the GPT-3 basically. Uh, Something which came out. Now this is a GPT-3 which come up with a different type of example-based training and all. Now I will compare all the GPT, just not on the performance, it's improved. The architecture wise also it's very huge. First GPT-1 model started with the 117 million parameter, then it's moved to 1.2 billion in the GPT-2, and GPT-3 was very huge with 175 billion. The architecture is also becoming complex. You from the 12 you are reaching to 48, and from 48 you are moving to 96 layers of decoder layers, like which is there in the transformer. The training data also mm, become huge, from 100 books corpus to 10 billion tokens to 300 billion tokens, and you improve on the sequence length also. Like the last GPT-3 models was able to adjust as per the 4096 sequence length. So that's the advancement happen in the GPT-3. But at core, it's a decoder-based model, auto-regressive, and it trained on the unsupervised learning and fine-tuned for some specific task. That's a way the GPT model trained. Any doubt with the GPT series? I try to make it very simplified, not go into very complex math of this model. But any questions, most welcome. Anything? It's making sense, these concepts for you guys, or it's very high level or something. That feedback is very important for me.
No, sir. We understand the concept very well.
Okay, great. Okay. Uh, so, uh, after 2020, 21, there is a very nice paper came from the OpenAI, which where they have not discussed about any architecture, but they are discussed about the like scaling law and emergent abilities of LLM. So here they call out LLMs mostly depends on three things: parameters, data which we are giving, and the compute. So as we scale out, we give larger number of parameter or larger number of data or larger number of compute. Anything we are increasing, it will increase the performance of the LLM. That's why you are seeing like uh, we are training bigger and bigger and models. We are even use the 500 billion parameter models. Okay, and it also call out the emergent capabilities. As use the model parameter, as use the data, as use the compute power we are providing, it will adapt to multiple tasks. So it's more like a tree. If your tree is small, it will cover the small number of tasks and it become a bigger and bigger branches to it. Branches is like a parameter and data, and you have roots, strong roots. Your compute, you can cover lots of tasks, like lots of area. So that's a very paper which very important in the generative AI, especially in NLP, in the LLM area, which shown us the pattern. If we increase the parameter, if we increase the data, if we increase the compute, our model capabilities will also increase. So that give the next 2 3 years uh, uh, goal that we have to work on these parts, like getting more data, more compute and all. So that make the shape for next few year of training and all. Okay. So till this is the way the LLM evolve, and this is the way the LLM train and all. Any question till here? And I am going out of time. Can should I stop, or you guys can give me for a 10 minutes?
No, you can proceed,
Uh,
sir.
okay. So this is the till here. This is the architecture and all. But the important thing was how we can get the best response from the model, and how to teach the model for some specific task and all, like which we want. So there is a after that there is a something called instruction and prompting came into the picture, and prompt engineers, there are separate papers and all, and the separate research happen around this. Still it's going on. Prompting is very researchable topic for the specific generative AI model, even not just for NLP, it's for images and all. Also, there are lots of visual transformer are getting built, and visual transformer also take the prompt. Prompt is mix of image and text, and and also how to teach model for a specific domain and all. So I will start with the prompting, few basic understanding. This is very important because without prompting, we can't 100% utilize the LLM. Okay. So prompting is a just very basic way to communicate with the LLM. So before that, before the prompting, if I will give the normal model work on completion rather than work on instruction. So prompting help you to make LLM to understand your instruction rather than completing your sentence which you are giving. So till the GPT-3 where we don't have any prompting and all, if you give the example, explain the moon landing to 6-year-old in a few sentences. So maximum GPT-3 type of model which not understand the prompting, it try to complete the sentence like in a different way. Explain the theory of gravity, like the token, just predicting the next few tokens to complete the sentence. But through prompting, we help it to take it as an instruction, and after that, the same models when it's taking the prompting and all, give us the answers. Like people went to the moon, they took picture of what they saw, send them back to the earth, so we could all see them. So this is the power of prompting. It helps you to uh, get the best response from these LLM models. So prompting, that's why it's evolving. There are multiple way we can even further get the right answer. So the question which you asked me in that Google page, like how if I'm giving the Krishna which institute example and how it will understand through the prompt, you can restrict your answer. You can help LLM to make answer for the Andhra region only, or for Tamil region only, like that. So prompting is also very important, where you can restrict the answer to a specific area, a specific part and all. So that's the power of prompting, and that's why it's very important. Uh, Prompt have a different. It's a so I will go further. I will directly go how the prompt generally get how to create a prompt. So prompt have four part. Any prompt. So there are few variation as per the company and the model. Llama maybe instruction they are calling as a system instruction. Context they are calling as a different. Input they are calling as a question. Output as answer. But uh, these are four main integrity of any prompt. Maybe the naming is different as per the company though who has the LLM and all, but the component or integrity where it's the same. So first, always go as an instruction. Instruction basically you are telling your LLM like what you are, like what you have to do. So just like for this example, answer LLM, we are telling answer the question only based on the context provided below. Keep the answer short and concise. Response unsure about answer if not sure about the answer. So this is the way we can what we are telling. You should not hallucinate. You should not make a generic answer. Only you will answer from the context below which I am providing about the quantify, and I want in very concise, like 1 2 words. And I, if you are not sure, like answer, you should not make any answer by yourself, you will just give me as a unsure about the answer. Second thing is context from where you need the answer. It may be of 4 line, it may be of 400 line, it may be 8192. The token you support may it cover 3-4 PDF for you. So that's a way context can be given to the any LLM. And third one is your question or input or what you want answer for, like who developed the centralized data platform using AWS. And these three things, once you provide as a prompt to model will give you the answer as output, which is quantify. It's follow all the instruction you have given, like keep it short and concise. Even if you give answer in a HTML format, it will can convert this answer into the HTML format and all. So that's the power of LLM. We can control the answer you are getting from the prompt, which control the answer you are getting from the LLM. Okay. And there are different technique. It's not just prompting. There are multiple technique of prompting. There is called program added prompting, iterative prompting, where you want to loop the like one answer should be context from for the next answer you want. You want to make a contextual question answer, case of prompting, chain of prompting. So there are lots of this is a whole new area which you can explore. Just giving you the overview. So by this, I want to just stop here on the LLM and all, like after times also. Any question till now? Any?
We'll take few questions. Participants, if you want to ask anything, any doubts, any information from him, please.
Even if you have any question later on, maybe.
Yeah, you can share your email ID or what.
Yeah, I will share I already shared my personal email ID also.
Okay.
So you can send me on the Google chat or something on my personal email ID. I will be happy to answer this.
Okay.
Okay. Thank you all.
Okay.
Yeah.
Yes. Tomorrow we will have again one more session. I think.
So I also need a few feedback. Like the way I have gone for this session is okay for you guys, or you want more technical or more application oriented, like something for the GAN? You can give me some hint, like how should I go for that?
I think today we have covered in application oriented or how LLM actually evolves. But tomorrow, if you go with technical details, that will be fine. Yeah.
No. Okay. Okay.
So thank you, sir. Thank you for joining and sharing your expertise here. Again, I think tomorrow you will share in detail, technical details, how exactly this is happening inside. And today you have shown the power of AI, power of LLM. Thank you so much, sir.
Yeah, not an issue. Thanks.
And thank you for the participants for patiently listening and joined in the online platform. Immediately, we are starting the second session. Manoj sir, you please
Okay, I will stop the recording now.
stop the recording and again start it so that.
Okay, thank you, sir.
So I'm dropping off. Thanks for everyone for attending this session. Thank you.
Yeah, thank you.